Hey guys, this looks like a fun one. The radius of the circle is 4. What's the combined area of the two squares? If you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. Let's give this square side lengths of x and this square side lengths of y. Does that make sense? Why? So the question is asking for the area of these two squares. So we're looking for x squared plus y squared. This is what we're trying to solve for. It is very important. Let's put a box around it and let's move it down here. Let's look at the diagonal of the pink square. And let's complete this angle right here. The diagonal of a square will always cut the corner angles in half, which means this is 45 degrees. And then we can draw this diagonal of the orange square, and this angle would also be 45 degrees. And this 45 plus 45 makes this entire thing 90 degrees. And let's give it one of these box labels. Next, let's complete this right triangle by connecting from here to here. Now, something really cool is going on. We have an inscribed angle that's 90 degrees. Anytime a circle has an inscribed right triangle, it will always stand on the diameter. Here's some notes right here. So this is the diameter of this circle. And we were told the radius of the circle is 4, which means the diameter would be equal to 8. Now if we find the other sides of this right triangle, we can do Pythagorean theorem. This side is a diagonal of this square. The length of a diagonal of a square is always square root of 2 times the side length. So this would be y root 2. Here's the notes for that. And it's very much related to these notes about 45, 45, 90 triangles. The hypotenuse is always square root of 2 times one of the legs of the triangle. And if you want to go even further back, all this is just Pythagorean theorem. You end up with side squared plus side squared equals diagonal squared. And after you go through all the work, you end up with the diagonals equal to the square root of 2 times the side. Pretty cool, huh? And then we can do the same thing for the diagonal of this orange square. It would be equal to x radical 2. And now we're ready for Pythagorean theorem. It's going to be this side squared plus this side squared equals this side squared. And then from here, this exponent will go to both the x and the radical 2. And this exponent will go to both the y and the radical 2. And let's copy down the 8 squared. This radical 2 squared is equal to 2. This radical 2 squared is equal to 2. And 8 squared is equal to 64. Let's smush everything together and then divide both sides by 2. These 2's will cancel each other out. These 2's will cancel each other out. And 64 divided by 2 is 32. And now we know x squared plus y squared is equal to 32. And that was the area of our two squares. So in the place of this, let's plug in 32. Let's give it a label of units squared. And that is the answer to our question. If the radius of our circle is 4 units, then the sum of the two squares inside of it like this would be 32 units squared. How exciting. And that's going to be true for all of these scenarios. We can move the squares around like this. All these pairs of squares will have an area of 32 units squared. And if you realize this ahead of time, you could have focused on this scenario where it's right in the middle. You would have recognized both of these are equal to 4, which would make both the areas 16, which would make the sum 32. But I think it was important that we went over it in the general case. How exciting.